Welcome to Filtration Matters, the regular podcast from BOFA, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and extraction system design are helping improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts will discuss how advances in extraction technology are helping optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Today we'll be discussing how automation in electronics manufacture is enabling the era of Internet of Things connectivity, whether that's domestic appliances, consumable wearables, autonomous driving, or industrial processes. In this innovative environment, the global market for PCBs is predicted to reach more than $80 billion by 2024. To provide insight into the systems that support the huge demand for electronics, including the extraction technology that protects production processes, I'm joined by Graham Mattok, BOFA's UK and Ireland sales manager, who has specialist knowledge of electronics industry automation. Welcome, Graham.
Good morning. I'm pleased to be here.
Graham, perhaps we could begin by finding out something about your background and how you've seen automation take hold in the electronics industry over recent years.
Yeah, certainly. I've been a professional fume extraction person for 20 years. The industry, when I joined it, was very much towards the electronics industry. In fact, at that point in time in 1999, there would have been probably about 80% of the extraction sold in the UK would have been towards electronics solder fume in particular. It's developed an awful lot since then, and even within the electronics industry, it's developed hugely as well, because at that time, most of the systems that were sold were solder tip or solder arm for manual assembly and rework. As the years have gone by and the electronics industry began to automate, at that time largely in Western Europe and the USA, and it moved into mass production. This was the time when the mobile phone was becoming extremely popular, and the companies that we knew at the time, the Ericssons and the Nokias, were taking hold, and they were producing in such bulk that the manufacturers were looking for ways to improve and throughput and product reliability as well. And at that point came the growth in particularly reflow technology, but also in wave solders and latterly in selective soldering as well for automated processes.
Thanks, Graham. So you mentioned a few of the automated processes that have become more popular. Let's just spend a little bit of time on each of those, if that's okay. So wave soldering, tell us about what wave soldering is.
Well, wave soldering is a slightly more traditional method. It's suitable for some but not all soldering. For instance, it's very popular in through hole type assemblies, and basically it does what it says on the tin. There's a solder wave created by a series of pumps, and the PCB comes into contact with the wave and carries out the soldering at a certain temperature.
And how about reflow soldering?
Yeah, reflow soldering is very popular these days. I think you'll find it in an awful lot of factories that are producing PCBs, because it's very efficient and very, very effective. What it actually does is it controls a process to the degree that an exact thermal profile is followed. So the flux is melted to a temperature which is neither too high nor too low, but causes the reflow effect and the attachment of the components to the board in a very efficient way. If you get that too high, if that thermal temperature rises too high, you'll might find like a balling effect on the flux. And if it's too low, obviously the flux itself doesn't melt and therefore doesn't work. So that profiling is absolutely vital in the reflow process.
And selective soldering?
Selective soldering is applied very often after a wave solder application where there are delicate components involved. So the delicate components might be wave soldered, or the board might be wave soldered, but the particularly delicate components may well be masked off for fear of the temperature profile causing damage, etc. So the selective soldering solders those vulnerable components.
And then there's something called conformal coating. Perhaps you could explain
yes.
what that is.
Conformal coating. Imagine something which was in a very critical environment, so a PCB in a very critical environment that might be vulnerable to maybe salt or any kind of materials which might cause it to degrade, maybe even rust, etc. So conformal coating is a coating which is applied to avoid that and give it an additional protection. You can imagine that's quite important in aerospace, etc.
And what about laser? Is laser employed in automated electronics?
Yes, laser marking of the boards is quite an important part of the process. It's not on every production line, but obviously the unique laser mark is quite an important part of identifying any product.
So I guess now would be a good time to talk about the emissions that typically result from electronics processes and how these can impact on operations and productivity if not effectively extracted.
Well, the traditional emission from any kind of soldering is colophony, which is caused by the resins, etc., within the solder products. That's largely the same thing with an oven. It's the same thing that's being produced. And if you let that into a room in higher volumes, the effect on the environment is quite obvious. So one way or the other, those fumes need to be ducted away. But in the case of automated soldering, there are other things to consider as well, particularly on wave solder machines where additives are added to the flux in the fluxer system, which is used to clean the board. So we have a gas filter as well, which is designed to remove anything VOC. Those are in relatively small quantities in the reflow and selective processes, larger quantities in the wave solder. So when we consider what we're going to offer in any particular process, the questions that we will always ask, because it's very important to ask questions. No two systems are the same, no two applications are the same, no two factories are the same. So it's very important that in these critical environments that the knowledge that we have is put to its full use, and the advice is given so that we can find the correct solution.
And what about conformal coating? Are there sort of any chemicals involved in that process?
Yeah, again, coatings come in many forms. Some are water-based, some are MEK-based. There are an awful lot of different chemicals, and also there's consideration in how they're applied. Traditionally, it was almost like a coat them with a brush and hang them out to dry situation. So ideal for our fume cab system, for instance. You could carry out the process and leave the boards inside the fume cab whilst the drying process took place. So therefore, no one's exposed to any of the fumes at all. And that still to this day is a fairly prevalent way of doing things. But we do have automated machines now. So it's kind of almost the same principle as a reflow oven. The conformal coating is being done in an automated system, which is quite good for fumes in a way because it's a more efficient way of applying the coating.
So maybe now's a good time just to talk about how BOFA goes about specifying an extraction system for an automated electronics process. What's the starting point and sort of how do you get to the end?
Sometimes it's very easy and sometimes it's not so easy at all. Most automated equipment has a fairly large operating manual attached to it. The kind of well-established reflow ovens and wave solders, and some of them have been around in this industry longer than I have and are still as relevant today as they were then. You begin with the manufacturer's recommendations. So the manufacturing recommendation may well be it needs so many meters cubed per hour. You work out how many different ports there might be on a reflow oven, and that can vary between 1 and 4. So you have to give due cognizance to that. Internal pipe work that might be inside the oven. A one-port oven will have internal pipe work because there's several zones within the oven. So we have to consider that. We have to consider siting. Where are we going to put the extraction machine? How can we install it? Because One thing about most electronics factories is that space is the one thing they're always short of. So we have to give consideration to how we best and most effectively duct the system back to the oven, or from the oven to the extraction system, because the more ducting you put on there, the less efficient the extraction system is. So, we try and do that as efficiently as we possibly can. And then the airflow setting with the IQ system, is designed to meet the ideal working condition of the oven itself. So, generally speaking, if the oven manufacturer says 600 meters cubed per hour per port, we would provide an extraction system which did just that.
So for the sake of clarity, now might be a good time to explain what a typical BOFA filtration system looks like. What's the setup?
If we talk about automated processes, most of the systems that are used are IQ systems. This is our intelligent system. This is the system that allows an operator at a glance to see what the machine is doing, and it also allows that same operator to maintain that flow with confidence. If the machine is set to run at 600 meters cubed per hour, and let's say the capacity of the machine was 1,000 meters cubed per hour, which means effectively that from the start you're running approximately 60% of the machine capability. That maintains that flow throughout the lifetime of the filters, or until the pump can't achieve the flow anymore. And that's dictated by the buildup of resistance through the filter system. But the IQ system detects this and warns and gives real-time information on what's actually happening within the system. So nice clear display. It shows that the pump's running. It shows the set point. It shows the actual point. It shows any faults that might appear on the machine. And also, there's the facility to interlink stop-start, for instance, and maybe filter change and fault signals into the PC of the oven or wave solder machine or whatever piece of plant it is.
Okay, Graham. So tell me a little bit about the sort of the filtration configuration that you might expect to see in one of these systems.
Yeah, the normal way on the types of systems that are used with automated processes consists of a three-stage system. So our machines generally work from the bottom upwards, so they call it reverse flow. The good reason for that is that very heavy particles can fall away towards the bottom of the machine and not clog up the filters. So the larger particles are caught in what we call a deep pleat pre-filter. The deep pleat pre-filter is made up of a number of different pleats, and it's designed to have the maximum capture availability pretty well of anything in its class. Beyond that, if any smaller particles get through down to 0.3 of a micron, there's a HEPA filter. Beyond that, and it's particularly important for wave soldering, is a chemical filter.
Okay, Graham. So you mentioned just now the IQ system and the visibility this gives to operational performance. What's the value of that to a manufacturer?
Well, the manufacturer is going to be very keen. I think we've already mentioned the thermal profile as such. It's very important for him to be able to maintain that. So on the display, there's two readings, one which is the set point. So that's the original set point that was set when the machine was first installed. And there should be a certificate of installation to benchmark what's required of the machine. So let's say the initial set point was 600 meters cubed per hour. What effectively now happens is there's an actual reading showing the actual airflow showed. And what that does is it gives the reassurance that the machine is performing as it was set to do. So that the benefit of IQ is that kind of close control, but also you can link the oven or whatever piece of plant it might be. It might even be a laser. There's lots of different applications. You can link that physically to the reflow oven so that the machine will start and stop at the same time. So there's no chance of forgetting to turn the extraction system on, for instance, which in practice does happen, some applications, or any kind of fault occurring without the oven realizing it. So that linkage is very popular. And I would say, in my experience or recent experience, certainly nearly everybody who takes this solution, prefers to have that connectivity, which works very well. And the other thing is that, in the event that something did go wrong, and there's lots of different scenarios, even like something in the pipe work, for instance, that might cause an issue, the IQ system allows us to remotely diagnose what that might be by means of a printout. So, within 10 minutes, if you like, of reporting a problem, we can be analysing that problem to let you know what it is.
So, of the extraction units that BOFA offers for the electronics industry, what would be the best fit for each of the process we've been talking about, do you think?
Certainly on the automated products, with the possible exception of the conformal coating at this stage, but certainly for reflow, wave and selective, we are definitely looking at IQ systems. Now, there are some very small reflow ovens and there are some very small selective systems and some fairly small waves as well. And on the contrary, there are some very large pieces of equipment as well. I think the IQ system is vital in all three because I think you need that real-time knowledge. You need to know what's going on because the process is so sensitive and so critical. So I think the one common factor here is IQ. Certainly, we've just put some reflow systems into a particular factory here in the UK, and we're just about to install a third and fourth. Well, in that case, it's quite easy because we're just duplicating what we've done before. But in the case of the first one, which to that particular company was a highly important one because they were using it as a if you like a demonstration of their capabilities to their customers. So they produced a production line of what they saw as very high quality, and our system had to fit into that. But it also gave us a template to work with the future systems. And we are working on an inquiry presently, which has its roots in energy costs, because venting out to atmosphere does potentially have quite a lot of cost, particularly if you're moving stuff around and having to make more holes in the roof, etc., etc., etc. Whereas you can just move our machines around to suit, and production lines do move. So you can just move our machines around to suit and not really have any environmental effect or cause utility bills to rise unduly.
So is there an understanding in the wider market about the benefits of portable extraction versus a vent-to-air system?
Yes, I think there's a growing appreciation of it as more and more of these machines are sold. Production lines are not fixed beasts. Wherever they are in the world, they're constantly being moved around into contract manufacturers in particular, who are also always taking on new contracts and have to reconfigure. But most electronics manufacturers of any size really are liable to move their lines around, and that involves quite a lot of work. If you've got a vent to atmosphere system, it might mean cutting new holes in the roof. It might mean redirecting some very large ductwork because they can be extremely large, these things. It might mean having to clean out large ductwork because obviously there's an issue with particulate lying around in pipes. Whereas our system, it's on wheels. When you move the reflow oven, you can just move the system with it, reconnect it, and away you go. It's dead simple. So there's a huge advantage in its portability there. Of course, the advantage of, or one of the main advantages of a BOFA system is that you don't have to worry about putting things out to the atmosphere at all. The air that's released from our machines is extremely clean. At 0.3 of a micron, particles have been captured. The carbon will have collected the VOCs in the air, and it's all really very clean.
Many thanks, Graham, for guiding us through the electronics automated landscape and how extraction technology is supporting workplace safety, innovation and productivity in a sector that's vital to all our lives in one way or another.
Well, it's been a pleasure, and thank you very much for having me.
If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.